Hello, this is Heather Dehn-Brastad, and today we're going to go over how to transform exponential and logarithmic functions. This is from Chapter 7, Section 7 in your textbook. So our objectives are to transform exponential and log functions by changing parameters and to describe the effect of changes in the coefficients of exponents and log functions. We can perform the same transformations on exponential functions that we performed on polynomials, quadratics, and linear functions earlier in this year. And maybe you even did this in Algebra 1 and in geometry. Here are the transformations of exponential functions. For a vertical translation, you will have your function and just add a number at the end. So if we have y equals 2 to the x, adding 3 after the 2 to the x will move it 3 units up. Subtracting 6 at the end would move it 6 units down. A horizontal translation, you subtract the number to the x term of the exponential function. So if you have 2 to the x minus 2, where that's now the exponent is x minus 2, that moves it 2 units to the right. Now you might think that's the opposite of what you expect, but that's the way it works for horizontal translations. If you want to move to the left, you actually add a number to the x in the exponential function. A vertical stretch or compression is when you multiply the whole function by a number. Usually for exponential functions, you will just see it written in front, like 6 times 2 to the x stretches it by 6. If you multiply by a number less than 1, then that compresses it. These are vertical. Horizontal stretches or compression, the variable will be multiplied by a number. And it's 1 over what you want to stretch or compress it by. So a stretch by 5 along the horizontal axes would be 2 to the 1/5 x, might be written as x over 5, and a horizontal compression by 1/3, the reciprocal of 1/3 is 3, so that would be 2 to the 3x. And finally, reflections across the x-axis, you just put the negative in front, so the whole function is the opposite, and if you want to reflect across the y-axis, just the variable, the x, has a negative on it. So this is on your worksheet, and you can come back to this whenever you need to verify what kind of transformation you have. This is just a directional shift. H is for horizontal. I don't know if that's going to help you much. All right, so asymptotes. We've talked about this a little bit before, but we need to make note of it, especially for this lesson, because if you're asked to graph and describe the asymptote is a line that the graph gets closer to as the value becomes really big or really small. So on this one, as the graph goes this way, it's approaching this line x equals 3. And as it gets really small, it's approaching x equals 3. The graph will never reach that value. It'll just get really close to it and stay really close to it. And there are asymptotes in exponential functions and logs as well. All right, so one of the type of problems that you're going to be doing on your worksheet, which you'll be using technology for, either Sketchpad or Desmos, is to translate just an exponential function. So you don't have to make the table of values if you're using Sketchpad or Desmos, but this is how you would do it if you had to do it on a piece of paper. You are going to graph g of x equals 2 to the negative x plus 1 and tell how that has been transformed from 2 to the x. So we're looking at this being our parent function, and we want to know how has this then been transformed from that. So we could go back to that table and say, the plus 1 at the end, I know that's going to move it up. And also the exponent, the exponent was negative, I believe, means that it's going to have a reflection about the y-axis, if that is the case. Let's see. Yep, the exponent's negative, so it's a reflection about the y-axis, and it will move up 1. Now we can graph it by plotting points, taking the negative 3 and plugging in for x, so that would be 2 to the negative 3, which would be 2 to the 3rd, which is 8 plus 1. That's where they got 9 from. And then for negative 2, you would have 2 to the negative 2, which would be 2 squared is 4, plus 1 is 5. And then 2 to the 1, because negative would be positive, would be 2 plus 1 is 3. And that 0, we would have 2 to the 0 plus 1, so just 1. Or just 2, sorry. 2 to the 0 is 1, 1 plus 1 is 2, and then so on. And you can plot those points, and if you keep graphing, you can see that it's getting really close to 1, but it never is going to reach 1, and we'll see that on the graph even better. So here, the red is g, and it's getting, the asymptote is x equals 1. The original function, 2 to the x, the parent function, has an asymptote of x equals 0. So we can see that it has moved up 1. The asymptote is now moved up 1, and it's also reflected across the y-axis just like we thought it should be. So here's one on your worksheet. Make it, and again, you don't have to make the table of values, but we're going to do the graph of 2 to the x, and then the graph of 2 to the x minus 2. So you might look back at our table, and we had it's just like this. It means it's going to move 2 units to the right. So if you can graph the parent function, our graph of f of x will just be 2 units to the right of that. And you also have to name the asymptote. So if we plug in values, you can see that the asymptote gets close to 0, but it never reaches it. And let's look at the graph. See there? So the asymptote is y equals 0. I think I said x equals 0 on the last page. It's to be y equals 0. Yeah, it was y equals 1 on this page. I might have said x there, but I didn't mean to. And the graph approaches this line as the value of x decreases. The transformation moves the graph 2 units right. All right, let's look at some more examples. We are going to find the y-intercept and the asymptote, describe how the graph is transformed from the graph of its parent function. And we're going to use for the parent function f of x equals 1.5 to the x. So how has this been changed? We can see that it is, the y-intercept is when x equals 0. So to find the y-intercept, you just put 0 here. 1.5 to the 0 power is 1, and 2/3 times 1 is 2/3. The asymptote is what it's approaching as the numbers get very large or very small, in this case very small. So here we have that the g of x is our transform function, that is the red line there, and f of x is the parent function. And the transformation is a vertical compression of the parent function by a factor of 2/3, because it was just multiplied in front by that. Here's another example with e. You can use e in your exponential functions. It's that special number that we talked about in a previous lesson. If you plug 0 in here, that's your y-intercept. You would have negative 0 plus 1, so that's just e to the 1, which is e. The parent function would just be e to the x. And then the asymptote, which is clear to see if you look at the graph, it is approaching h of x, that's the red line, it approaches 0, y equals 0, that's your asymptote. F of x, the parent function, is also graphed, that's the purple line. This is a reflection across the y-axis, and it's also, because of the plus 1, it's also moved to the 1 unit to the right. It should have moved 1 unit to the left. Oh, it's because of the negative. Okay, so we're going to look at graphing these on your worksheet using Sketchpad, and I have that all set up. But before we move to that, the transformations for log functions, logarithmic functions, are very much the same. Instead of, 2 to the x, we have log of x plus 3 means you're moving up 3 units, and log of x minus 4 is down 4 units, and so on. Horizontal translations, you add or subtract the number inside the parentheses, and vertical stretch or compression is multiplied to the whole function, whereas horizontal stretches or compressions are multiplied just to the variable. Reflecting across the x-axis is you put a negative in front of the whole function. Reflection across the y-axis is when you have a negative just on the variable. And you can use log or natural log, the ln, because they both work the same. So in this example, if you're going to graph 5 log of x minus 2, the parent function is the purple one then. That's just log of x. How has the red line, the transform function, changed? You can see that it's 2 down, and then it has been multiplied by 5, so there's a vertical stretch by a factor of 5. And then, like I said, a translation 2 units down. And then natural log of negative x plus 2, the parent function would just be natural log of x. So if we graph it, we can see that the asymptote is right here at x equals 2. The h of x is the red line, and it is reflected across the y-axis. The negative part tells you that. And the plus 2 tells you that it has been shifted 2 units to the right. Sometimes you have to write transform functions. This is the last part of your worksheet. And in this one, we're going to take f of x equals 4 to the x, and we want to reflect it across both axes and move it 2 units down. So if we want to reflect across the y-axis, we put a negative on the variable. And if we want to reflect across the x-axis, we put a negative in front. And if we want to move it 2 units down, we will subtract 2. And there you go, there's your transform function. It's standard that if your original function is f of x, that you will change it to another letter for your transform function, like g of x or h of x. Here's another example. F of x is the natural log of x, and it's compressed horizontally by a factor of 1/2 and moved 3 units left. So first we write down the function, natural log of x. They skipped this part. That's an L. And then in order to move it 3 units to the left, you would add 3 to the variable. And in order to compress horizontally by a factor of 1/2, we take the reciprocal of that as 2 and put the 2 right there. So it's kind of squished. So there we have it. And then they graphed both of them too, so you could see that that indeed has been compressed horizontally, the red line, and it also has moved 3 units to the left. All right, so now we're going to look at some of the problems from your assignment. So yours, you can either do it in Sketchpad or Desmos. I'm going to do it in Sketchpad because it's all set up here. Oops. So on the Sketchpad, I have several pages that you're going to do, and one of them is a page of notes. So on your page of notes are some of the things that we've looked at already, the transformation of exponential functions, the transformations of log functions, and the information about what an asymptote is. And then we'll go back over here to page 1. So number 1 says to find the y-intercept and asymptote for each function, then graph each function and the parent function, and then they tell us what to use for a parent function for 1 and 2 on the same plane, and then tell how it's transformed from the graph. So there's several things you have to do for each of these problems. Not a lot of them to do, but several steps. So let's graph the parent function first. So you go to Graph, Plot New Function, and the parent function is just 2 to the x. So 2 to the x. So here's our parent function. Then we are going to graph our new function, which is 2 to the x plus 2. 2 to the x. And then I don't want the plus 2 to go on the exponent, so I'm just going to add 2 and see. And then I check up here and see if it matches, and it does. If you want the 2 to be added to the exponent, I'll need parentheses around. And I don't on this one. Okay, so there's the transformed function. One thing I like to do is change the color. So I go to line style, no, line color, and then I'll just change it to, red. So my transformed function is the red one. All right, where does that cross the y-axis? What is the y-intercept? You can see on the graph that it's 3. You could also put 0 in for x and solve. So 2 to the 0 would be 1. 1 plus 2 is 3. So the y-intercept is 3. The asymptote, oh, I already wrote down what the asymptote is y equals 2. You can see that it's approaching 2 right here, which is here as well. And also, how has it been transformed from your parent function? If you look at the function 2 to the x plus 2, that should give you a clue at what the transformation is. Or you can see that it has moved from the y-intercept at 1 up to 3. The transformation is up 2 units. So it has moved up 2 units. That's the transformation. It's a, I suppose I should say it's a translation. Translation. There. Okay, and then number 2 looks very similar to that. This one, when we do graph, first put your parent function on there again, which is 2 to the x. When you graph the next one, this is where the 2 is part of the exponent. So we're going to graph 2 to the parentheses x plus 2, which will change the way. See, now the x plus 2 is that whole thing is the exponent like we wanted it to. So when you graph it, that's going to be a different type of transformation than this one was. And then you answer the questions about the y-intercept and the asymptote and what the transformation is. And that's what you're going to be doing on many of these problems. You will graph the parent function, which is y equals 2 to the x again, and then graph the new function 5 times 2 to the x, and then tell what the y-intercept, the asymptote, and how it's been transformed. Just to show you how to graph number 4, so the parent function this time is 5 to the x. There's the parent function. And the transformed function is 5 to the x over 4. So let's look at that. 5 to the, use parentheses, and go x divided by 4. And then close your parentheses. And that looks, yep, just like that. And let's, again, change the color so that we can tell which one's which. So the transformed one is red. And then you'll answer some questions about how that has been transformed. And if you need to, you can look back at the notes page at any time. And if your exponent is being multiplied by a fraction like that, then you can see that that is a horizontal stretch by 5 by the reciprocal of that number. Okay, what page was I on? 4. And then we have some log functions. The parent function is going to be the natural log of x. And that is found by going to functions and then going down to natural log. And then we need the x there. That's the parent function. And note that this one does not ask us to find the y-intercept because this is an asymptote right here of x equals 0. So instead of having an asymptote that is a horizontal line that's y equals something, it will have a, let me fill that in, it will have a vertical line asymptote. So the parent function, I shouldn't put that in here yet because the parent function has an asymptote of x equals 0. But the transformed graph, let's check this one, natural log of x minus 2. So again, go to functions, natural log of x, and then I need the minus 2 part. So I clicked outside the parentheses and then I wrote minus 2. And that moved it down 2 units. So that's the transformation. And the asymptote is still going to be x equals 0. Number 6, again, is very similar to the last one. The log function, when you graph this, the parent function will be log of x. And that also can be found in the functions box. There's log of x. This is the parent function. And you'll see that this one too, the asymptote, it's not going to be a y equals asymptote, it's going to be an x equals asymptote. This one has an asymptote of x equals 0. They could make that continue a little closer, but I guess they can't get it close enough. And then you can see when you graph log of x plus 5, if the asymptote changes, I bet it will. Log of x plus 5, and put the plus 5 right in the parentheses with it. And it moved it over, so now the asymptote for this one is not going to be x equals 0, it's going to be x equals negative 5. Here's another one. And then on 9 through 11, you're going to write the function after it has been transformed. So you'll use these guidelines to change this equation. Start by writing this equation down, and then change it the way they tell you. Like translated down 4 units means subtract 4 at the end. And what does it mean to reflect across the y-axis? So you'll look that up too, and then put the negative where it belongs. All right, so that's it. When you're done, save your Sketchpad function. Remember that or your Sketchpad file. Remember that to attach it, you have to stay logged into your Minnows Virtual Student Desktop, because that's where it's saved. Log into Blackboard, go to our course, and then attach it to your assignment. Thank you very much, and let me know if you have any questions.